Let me move me into the video because nothing makes me feel better about myself on a Monday morning than having to look at me on a video. So what we are starting on today is section 5.2. Oh my God. Verifying trig identities. I think what I'm going to spend next period doing is seeing if I can get my old whiteboard app back. When we're verifying trig identities, they're going to give us both pieces. For example, if I have, if I'm asked to verify secant squared x minus 1 over secant squared x equals sine squared of theta. Sine squared of x. Sorry, it's theta on my paper, and I put it as x here, and so now I'm confusing myself. What it's saying is I need to show how I get from one piece to the next piece. We know what the answer to this is. We know that secant squared x minus 1 over secant squared x equals sine squared x, right? It tells us that. We need to show how it got there. When you're doing this, you're always going to start from the more complicated side, right? In this case, our most complicated side is the secant square of x minus 1 over secant squared of x, right? Because sine squared of x is pretty simple, right? So what we're doing is we're going to show how we get from one to the other. And the way we're going to do that is by using the trig identities. If I look over here at my trig identities, I've got secant squared of x minus 1. So I'm going to go through and see what I've got that has a secant square in it, right? Or a secant. Anytime I see this minus 1 that I made look like equals 1 by getting crazy with my pen. Anytime I see a secant squared or anything squared with a 1, I'm going to look towards my Pythagorean identities, right? And here, if you notice, I have secant squared of theta, I have tangent squared of theta, and I have a 1. If I were to subtract this 1 from both sides, I'd have secant squared of theta minus 1 equals tangent squared of theta. Would I not? Right? If I have 1 plus tangent, we'll call it of x, tangent squared, equals secant squared of x. If I just subtract that 1 from both sides, I wind up with tangent squared of x equals secant squared of x minus 1, which is exactly what we have here. So I can replace that with tangent squared of x over secant squared of x, right? Did you guys follow? Well, now I'm going to look at how I can break this down even more, right? Now, one of the things that I know is that secant squared of x is, or secant and cosine work well together, right? Secant is equal to 1 over cosine. So I could write this as tangent squared of x over 1 over cosine squared of x. And then if I remember how to deal with fractions, I can go tangent squared of x is equal, times the reciprocal, right, which is cosine squared of x over 1, which is just cosine squared of x. And we're not there yet, but what I do also know is that tangent is equal to sine over cosine. How do I know that? If I don't remember it, remember I have all of these listed already. So this would be sine squared of x over cosine squared of x times cosine squared of x over 1. When we're multiplying across, we can cancel those, right? Because if I multiply, I might have cosine squared of x over cosine squared of x, which is just 1. And I'm left with sine squared of x. So we're talking about how we get from one spot to the next. The good news for you guys is normally you would just be given this problem and you'd have to find your own way through it. And that's how you would normally do a set of problems like this. But when I was looking through the web assignments, they give you part of it already, right? And you're filling in the blanks. So it does give you a little advantage of kind of knowing which way to take it. You're not completely left on your own to figure out how to start verifying and where to look. But these are puzzles, and you're talking about a puzzle, like how do I get from one spot to the next spot? And all of the pieces of that puzzle that you have are up in here in our identities, right? That's where we're going to find all of the pieces to this puzzle. Now I'm just going to go ahead and do a few more examples of these and then send you on your way. I hate that I have to switch back and forth now. And we're just going to keep bringing the identities down with us every time we do a problem. If I am asked to, for example, verify 2 secant squared of alpha equals 1 over 1 minus sine of alpha plus 1 over 1 plus sine of alpha. In this circumstance, I'm going to start with the right-hand side, that addition side of the equal sign, because it is the more complicated side. You always want to start with the part that's more complex, because it's easier to simplify something big down to something small than try and grow out something small to match your more complicated side. And so we are going to start with this part, right? And ultimately, all we are doing in this part is we're adding fractions. And what do I need when I'm adding fractions? So if I have 1 over 1 minus sine of alpha plus 1 over 1 plus sine of alpha, what do I have to have if I'm adding a fraction? It doesn't matter what fraction it is. If I have 2/3 plus 3/5, what do I need in order to add those fractions together when you're adding and subtracting fractions? Right, same denominator. You need to have a common denominator. Now, if I look at this one, I've got 3 and 5. So if I multiplied this times 5 over 5 and this side times 3 over 3, I would wind up with 10 over 15 plus 9 over 15. And then I could just go ahead and add them together, right? I'd have 19/15. Same thing is happening up here when we're talking about adding these two fractions together. We need to have a common denominator, which we do not have right now. It looks similar. They have similar denominators, but they are not the same, right? Because this one is 1 minus sine of theta, and this one is 1 plus sine of theta. And so what I'm going to do is I'm going to take this side and I'm going to multiply it times this denominator, which is 1 plus sine of theta over 1 plus sine of theta, right? I'm going to put parentheses around this to remind myself that I have to distribute. On this side, I am going to multiply times this denominator, which is 1 minus sine of theta. I keep saying theta, but it's alpha, over 1 minus sine of alpha. Have to multiply the top and the bottom because that's the same as multiplying by 1, right? Anything over itself is 1, and I'm not changing the value of any of it. So let's see what we get here. When I multiply this times 1 and distribute it, anything times 1 is just itself. So my top here is going to be 1 plus sine of alpha. But if I look at the bottom, right, when I multiply 1 times 1, I get 1. 1 times negative sine of alpha is negative sine of alpha. Sine of alpha times 1 is plus sine of alpha. Notice our bottom, this is going to just completely cancel, right? And here I'm going to go sine of alpha times sine of alpha. Negative sine of alpha is negative sine squared of alpha. And then when we do the same thing over here, 1 times the top is just going to be itself, 1 minus sine of alpha. And we are going to wind up with the same bottom. I could take you through it step by step, but here we have 1 plus sine of alpha times 1 minus sine of alpha. We're going to be left with this same thing on the bottom, right? 1 minus sine of alpha plus sine of alpha minus sine squared of alpha. And if I rewrite those, which it's really fairly easy to do, if we simplify this, right, this is going to cancel out and this is going to cancel out. Minus sine of alpha plus sine of alpha is just 0. And we are going to be left with 1 plus sine of alpha over 1 minus sine squared of alpha. And since they have the same denominator, can't I just put these together too? This would be plus 1 minus sine of alpha, right? I can do that because they have the same denominator. I'm just combining those two things. And if I look at this, I have 1 plus 1, which is 2. And I have plus sine of alpha minus sine of alpha. Well, that's just 0, so we lost all of that. And we've got this all over 1 minus sine squared of alpha. And so what are we looking to get to? Do you remember what we're looking to get to? We're trying to get to 2 secant squared of alpha, right? Well, we've got the 2, and now we have this 1 minus sine squared of alpha. If I'm dealing with something like that, I'm going to look to my Pythagorean identities and see what I can find there, right? That might help me out. Now, 1 minus sine squared of alpha, if I'm dealing with sine squared, I think I would look at my sine squared of alpha plus cosine squared of alpha equals 1, right? And we're saying 1 minus sine, so I'm just going to subtract sine squared of alpha from both sides, right? And I would see that cosine squared of alpha equals 1 minus sine squared of alpha. Now, I kind of know, like I see these in my head now, so I don't really always have to do the work to get there. And you'll start to do that eventually. But what I want you to keep in mind is that this is how we get those things. So this is going to leave us with 2 over cosine squared of alpha, right? Because it's equal to 1 minus sine squared of alpha. I can just interchange them. And then our last bit is we're trying to get to secant. Well, cosine squared of alpha is 1 over secant. And so secant is just 1 over cosine. And here I have 2 over cosine. So that is just going to equal to secant squared of alpha, which is what we were trying to get to, right? It was the original plan was to get to 2 secant squared of alpha, and we worked our way there. Now, I know that this is complicated stuff, sort of, right? Because it's new, but all of it is going to be the same. I could do, like I have 4 more examples of this kind of problem, but I don't think you need to see 4 more examples of this kind of problem. What I do want to show you is that when you can't find anything in the trig identities right off the bat, now I got all this stuff stuck to it. If you can't find anything in the trig identities right off the bat, what I would do is, if you can convert everything to sine and cosine, do it. What I mean by that is if I have, for example, let's bring that back. Let's bring back the thingy. If I have to verify tangent of x cosecant of x equals secant of x, I'm going to take this and I'm going to change anything I can to all sines and cosines. Like I know that tangent of x is sine of x over cosine of x, right? So everything at this point on that part is a sine or cosine. I know that cosecant of x is 1 over sine of x. So now I have these multiplied together, and this is going to cancel, and I'll be winding up with 1 over cosine of x, which just, if we come over here, can see is just cosecant, where'd it go? It's just secant of x, which is what we're looking for, right? So when you can, if given the opportunity, switch everything to sine and cosine. If I had new example, tangent of x plus cotangent of x, I'm like, looking at the same problem again, equals secant of x times cosecant of x, right? I'm going to go ahead and I'm going to switch this to sine and cosine, right? So this would be sine of x over cosine of x plus, well, cotangent is the same as tangent flipped. It would just be cosine of x over sine of x. We're adding here, we're not multiplying, so we can't just cross things out. We would need to find a common denominator on this. Well, for my common denominator on this side, right, I just need a sine. So I would multiply this times sine of x over sine of x, right? And I would multiply this times cosine of x over cosine of x, right? And here I would wind up with sine squared of x plus cosine squared of x all over sine x cosine of x. And then we can see that we have that Pythagorean identity right there. If I look up here, I can see that sine squared of x plus cosine squared of x just equals 1. So I have 1 of sine of x times cosine of x. And if I split that up even more, I could rewrite that as 1 over sine of x times 1 over cosine of x, right? Oops, I don't know why I wrote c there. And we know that that would just be cosecant of x times secant of x, which is what we were looking for in the first place, right? They're in opposite orders, but it's multiplication. So it doesn't matter. Order doesn't matter. So if all else fails, one, always start with the most complex side, right? It's easier to break something down than it is to expand it. And then if you can't find anything, try and turn everything into sine or cosine and see how they cancel out that way. And it should get you to where you want to go. I understand that this is complicated, and this will be your only assignment this week. So when I see you guys on Thursday, I hope you will have tried to do some of these with the homework so that you can ask the questions that you need to. I'm going to stop the video and then I'll answer any questions anybody has. And then I will let you guys go.